Right, so eg6 is the first example now where we are actually moving, or particles actually moving in two directions. So eg6. A particle is projected from a point O on a horizontal plane with speed 28 meters per second and with an angle of elevation of 30 degrees. After projection, the particle moves freely under gravity until it strikes the plane at point A. The first thing they want us to find is the greatest height above the plane reached by P. So let's put some information onto this. Now our particle is being projected from the horizontal plane. So it's firing off at an angle of 30 degrees to the horizontal, angle of elevation, with a velocity u of 28 meters per second. The thing is still moving in a parabola, so even though I've drawn an arrow there, this thing is going to move like that. And we're interested first up in the greatest height above the ground. So the greatest height is at a particular instant where it's no longer moving in a vertical direction. Up until that point it's climbing, so it's moving in the horizontal direction and in the vertical direction. But at the instant it's reached its maximum height, it has got no more vertical motion. So at max height, Vy equals 0. So just like with all the previous examples, it's got a horizontal component of velocity, which is always equal to its initial horizontal component of velocity. But while the vertical component changes, at the maximum height it's actually equal to 0. So we know that at that maximum height Vy is 0. Also, because we have here initial velocity which is acting at an angle, we need to work out what the horizontal and vertical components of that are. And the horizontal components is going to be, if we imagine, and you'll soon get to the point where you can just write this down, if that is 30 and the hypotenuse is 28 and I want ux, that's going to be using right angle trig adjacent over hypotenuse, which is cos. So ux over 28 equals cos of the angle, which is 30 degrees. So ux is 28 cos 30, and then similarly uy over 28 will be opposite over hypotenuse, which is sine 30. So uy is 28 sine 30. Now in your pure maths you will have, I'm sure, recognized the third form of cos and sine 30. Sine 30 is a half, so uy is going to be 14, and cos 30 is root 3 over 2, so that's going to be 14 root 3. When you are answering these questions, you don't have to lay that out. You can just write those straight down. It's a given that you will know how to get the vertical and horizontal components of that. In the same way that when you're breaking down forces in AS into components of force, it's the same principle that's being applied. So part A, the greatest height above the plane. Well, what I've got, what I know, so at the maximum height, Sy equals h, and that's in the positive direction because it's above our point of projection. AY is minus 9.8 because it's pulling downwards. It's fighting the motion of the particle. UY is 14. And we don't know the time. But it's one of the things we have to find out. So at the maximum height, we have that set of information. And we are going to use, first of all, V equals U plus AT. And we got nothing to do, we got no information on horizontal motion, so we don't need to do the vector part of it. We're only going to actually use Vy, which we know is 0, equals Uy, which is 14, minus 9.8 t. So the time is going to be 14 over 9.8, which is 1.428 or 10 over 7. So leave it as a fraction for the time being. So that's 10 over 7. So that's the time to the maximum height. So now using S equals UT plus a half AT squared. The only thing I don't know now is H. So U is 14, 10 over 7, plus a half times minus 9.8 times 10 over 7 squared. So the easiest way to do that on my calculator, you could work it out anyway, is I'm going to store 10 over 7 in X, and then I can write 14x minus 4.9x squared, which is 10. So the maximum height reached by the particle is 10 meters above the point of projection. Okay, let's go back to the question. The time of flight of P. So for the time of flight of P, if we consider the whole journey, when it reaches the ground, its vertical displacement is 0, because although it's risen as high as 10, it's actually then falling back to ground, so the vertical displacement is 0. So part B, over whole flight, vertical displacement is Sy equals 0. So using S equals UT plus half AT squared, 0 equals Uy, which is 14 T, plus a half minus 9.8 T squared. So 4.9 T squared minus 14T equals 0. You can take T out as a common factor, leaving me 4.9T minus 14 equals 0. So either T equals 0, so to have that 0 displacement that we were looking at, so that it's back at the same vertical point as it started, it's either going to be when T equals 0, which is the point of direction, point of projection, or 4.9 T equals 14, T equals 14 over 4.9. So 14 over, can't quite see that, 4.9 equals 2.85, so same thing, write down the decimal string, 2.9 sec 2SF. Okay, so the time of flight is 2.9 seconds. Let's go back to the question. Part C, the distance OA. So they may call it the distance OA, they may call it the horizontal range. Different questions could pose that differently. So what we want to know now is we know what time it reaches that point. All we need to do is work out what, so what we have there is x comma 0. So this is part C. So horizontally now, considering the horizontal motion, considering the horizontal motion, Sx equals x is what we're trying to find. We know that Ax is 0. We know that Ux, we've worked that out to be 14 root 3. And we know that the time is 2.875, which if we SD it, or you probably wouldn't need to on yours calculators, your calculators use a fraction anyway, we keep that whole string in and re-round afterwards. So using S equals ut plus half at squared, S equals x, u is 14 root 3 times 20 over 7, plus, and that's 0 because Ax is 0. So that works out to be, what have I got there, 40 root 3 meters. So times 14 root 3 equals 69.282, blah blah blah, round to two significant figures, 70 meters, two significant figures. So that's it. That is example 6.